Because the previous model we trained is very simple, as it only uses one feature, which is length, then we can probably consider including one more feature, such as lightness, the lightness of the color, right? So we can measure its lightness using some tools, right? And the lightness feature may reflect another pattern, okay? So for example, there are some measurements of lightness here. If it's above 5.5 something, lightness is over 5.5, then it is more likely to be a CBAS, right? Because the majority of the CBAS is on the right half of the histogram. And if it's below 5.5, then it's probably salmon, okay? The same way as the length feature we did before, okay? So here's a second classifier. Well, if we use the second feature, lightness, as one individual feature, then it'll be the same way as the previous feature, okay? So now what we can do is that we can combine the two features together, right? So for example, we can use the two features together, and the length as the y-axis and the lightness as the x-axis, and we plot the category of fish among this 2D space, okay? So in this 2D space, we can see a pretty clear pattern between salmon and the sea bass, right? Basically, we can see a boundary between salmon and the sea bass indicated by this line plotted here. And on the right half, it's almost sea bass. On the left half, there's the majority is salmon. And there's some a little noise here across the boundaries, but it is much nicer than using just one feature alone. Okay. So in this case, the features we use become a vector. It is no longer a single number. It is a vector of two elements. The first dimension is, the first element is lightness, and the second is length. Right? Okay. So given any points, any fish in our data set, in our bag, is represented by a point in this 2D space. Okay. The salmon here in the blue circle has lightness 2.1, the length 16.5, right? And the sea bass here is lightness 6.8, and the length as 20. So all the objects in the real world are represented by a feature vector, okay? We call this vectors feature vector, okay? One fish can be represented by a feature vector. Okay? So basically any kind of fish can be represented by a feature vector. All right, so, but we need to be careful because not all features are good ones to use. For example, number of eyes, it doesn't tell the difference between salmon on sea bass at all, right? Basically, all kinds of fishes have number 2 eyes. And weight is probably a good feature, right? But if weight is also strongly correlated with the length, it maybe doesn't add too much information to the model. And color, it may be useful, which we don't know. And smell, it is could be a good one, right? So adding features is okay, right? We can always add more features, but the performance matters because sometimes adding features may result in good models, but sometimes it could result in bad models, but not result in bad results. Okay. So different models can draw boundaries differently, which we've already seen, right? So using one length as feature, the boundary we draw is just a 1D curve, is a 1D line, right? And if we use two features here on the upper right corner, we can draw a linear line as a feature. Of course, we can refine the decision boundaries because in this linear boundary, there are some noisy data that cross the boundaries, right? So if we want the model to be perfectly accurate, we can always reshape the boundary, okay? We can reshape the boundary by excluding noise data, right? So if we draw the boundary a bit, with a bit curve, then it's probably more it will probably give less errors or give less mistakes, okay? So the extreme case is that we carefully design every corner of the boundaries so that we make sure that any points beside the two boundaries, they are correctly accurate, or almost every data points. But we'll see later in later chapters that this kind of model is not the best option, is not the best choice, because these kind of boundaries fit the data so well, fit the existing training data so well that it doesn't represent the general patterns over the real world data distributions. Okay, so that's about how we represent data using a simple binary fish classification model or fish classification tasks. Right? We gotta choose our features carefully. We need to collect training data, a bag of fish. We need to represent each data instance with feature vectors, and we need to choose a model. Right? That is a way to draw boundaries, and then we train a model with training data, and then we make predictions on new data. So that is the typical workflow of how we do data representation for simple supervised learning tasks. And then later in the next video, we're going to talk about the difference between supervised versus unsupervised learning.